This is a presentation by Challenge 1A, and the work is done by Rookie PMO II. First of all, I would like to thank all my team members, Ren, Jai, Yiling, Yajing, Jason, and Bingxue. So I would like to summarize our challenge. So when workers get tired, their quality decreases and the risk of injury increases. Traditional shift schedules do not take into account workers' productivity curves. To improve the efficiency and save costs, we aim to optimize shift patterns for over the 3 million construction workers in the UK based on wearable devices and statistical algorithms. For user personnel, we've got 3 different roles. For planners and senior managers, the jobs involves planning and scheduling, including determining how to get a project built as efficiently as possible, estimating the cost of materials, labor, and equipment for a project, quality control and quality assurance, including regular site inspection, coordinating the creation of documents, including sketches and drafts, and monitoring the project budget and spending. For construction workers, they do a wide range of tasks, from the very easy to the extremely difficult and hazardous. Some tasks do require some training and experience, but most of the jobs usually require little skill and can be learned quickly. They need to clean and prepare construction sites by removing debris and possible hazards, loads or unloads building materials to be used in construction, operates or tend equipment and machines, such as concrete mixers, and help other craft workers with their duties, follows construction plans and instructions from the people they're working for. According to their daily work, we summarize their user personnel and aim to develop a user-friendly solution. This is our solution. Our solution starts with wearable device technology provided by McVic. Huge thanks to McVic. The fatigue data of construction workers can be collected through the sensors inside the helmet. Considering external factors such as daylight hours, weather, supply chain problems, and others, we develop a data-driven model to generate a smart shift schedule which is able to maximize the workers' productivity and lower the company costs. For smart shift schedule, it is in the form of the interactive data dashboard on Power BI, including functions of, first of all, cost analysis, then shift schedule, finally, cost calculator. So the workers' productivity can be inspected by wearable sensor data. Through the historical data on site, we can summarize 2 points. First of all, based on the cost analysis, we found out that Wednesday has highest efficiency and Friday has the lowest efficiency, and 2 breaks schedule has higher efficiency than just 1 break. So essentially speaking, it is always better to take more breaks, but we've got at most 2 breaks. Second, using our smart shift schedule, we optimize 2-break scheme by reducing 9.3% cost. Here we go with a little bit technical details. It is about the statistical model behind smart shift schedule. We applied curve fitting strategy to generalize a model based on the given dataset. Raw fatigue level data is segmented into 3 different time periods categories: start of the day, break period, work period. After mathematical analysis, we conclude to use polynomials, sigmoid functions, and linear approximations for these 3 different categories. Hyperparameters of each approximation function is tuned by Python, and final daily shift curve is generated as piecewise function compounded from these 3 different categories. Cumulative productivity then can be produced by integrating the function, just calculating the area under the curve. Our model reveals the optimal break and work durations are 80 and 150 minutes respectively, and the first break should be placed 2 hours after the start of the day. Finally, I would like to summarize our work. Overall, the smart schedule generated from our data-driven model can maximize the productivity of construction workers and minimize the costs of the company. Our model considers workers' behavior and fatigue level in addition with external factors. The product we design is easy to use by managers and workers. Finally, our statistical model is parameterized and it is adaptable for any dynamic changes when new data is coming. We have 3 questions from the judges. Question 1. How has the solution been tailored for technical skills of the target audience? So our statistical model can be updated automatically in the backend. The shift schedule is delivered in a digital form on an app and can be printed out. Therefore, our users can use our system easily just by downloading the app or downloading the form. Question 2. Can the solution be modified as data becomes available or unavailable? The answer is yes. As reviewed by our statistical model, the model is parameterized, which means you can make reasonable assumptions when data is unavailable. Once we have new incoming data, the model can be updated for high accuracy by modifying few parameters. The final question. There are multiple methods for organizing projects. How does the solution adapt to these different methods? So our solution is customized for the construction industry. In terms of other methods of project organization, our statistical model can also be adapted by introducing more parameters. For example, if you have more variables, just introducing this variable into the model and introducing more parameters and apply the algorithm we introduced before. By tuning the parameter, we still can get a nice model. Okay, so this is the overall presentation of the challenge and our project. Thank you for listening.